Hi, my name is Yann Stoneman, and today I'll be doing part 2 of going over the Streams DSL documentation for Kafka. And I'm doing it kind of just as a study with me video where I just read out loud the documentation and I pause when I have questions about it. Sometimes I look stuff up, sometimes I comment on what I think about it, just as a way for me to learn. And I've found that I learn it better when I record it, and I've gotten some feedback that it helped other people, so I'm continuing to do it. Hope you enjoy, hope it's useful. All right, so creating source streams from Kafka is where we left off. So creating source streams from Kafka. You can easily read data from Kafka topics into your application. The following operations are supported: reading from Kafka and description. Okay, so this chart here that they have in creating source streams has 3 types of sources: input topics into KStream, or input topic into KTable, or input topic into Global KTable. No surprises there. You've got KStream, KTable, and Global KTable. Now it's going to talk about, I guess, the differences in creating one of those. Creates a KStream from the specified Kafka input topics and interprets the data as a record stream. Okay, I'm going to read that again. The input topics to KStream creates a KStream. Okay, well, I would expect when you're creating a KStream that you would create a KStream. Yep, I'm on board with that. Creates a KStream from the specified Kafka input topics. Right, if you're putting in certain input topics, I would hope that that's what the KStream is made out of. And then it interprets the data as a record stream. Okay, now I'm curious to actually compare the first sentence for these 3. So for KTable, reads the specified Kafka input topic. Okay, so far it's the same thing, but into a KTable, and let's see what it interprets it as. The topic is interpreted as a changelog stream, where records with the same key are interpreted as upsert, aka insert, update, blah, blah, blah. Just to compare the first sentence, the difference here between the KTable and the KStream is that with the KStream, the topic is interpreted as a record stream. The data within the topic is interpreted as a record stream in the KStream. And with the KTable, the data is interpreted as a changelog stream. And then with the global KTable, the topic is interpreted as a changelog stream. So same thing. But then the differences between the global KTable and the KTable is a bit more in the meat below here. So getting back to the first description, the one about the stream, a KStream represents a partitioned record stream. In the case of a KStream, the local KStream instance of every application instance will be populated with data from only a subset of the partitions of the input topic. Collectively, across all application instances, all input topic partitions are read and processed. Okay, so just digesting that a bit. In the case of a KStream, the local KStream instance of every application instance will be populated with data from only a subset of the partitions of the input topic. Okay, so an input topic has several partitions, and the KStream instance, I guess that's the actual hardware or virtual hardware running the KStream, that will only get a subset of the partitions of the input topic. That kind of makes sense. You wouldn't want every instance handling every partition, because otherwise, how are you going to scale horizontally? Collectively, across all application instances, so a single application instance is going to just have a subset of the partitions. But when you sum them up, when you have all application instances together, you are going to make sure that all input topic partitions are read and processed. So not a single application instance does all the partitions, but across all of the instances, they've got it. Okay, that's what that means. Import org Apache Kafka common serialization Serdes. And so we've got some Java code here. So importing 3 libraries, I guess the common serialization Serdes for serializer, deserializer, streams, streams builder, streams, KStream.KStream. So we've got serializer, deserializer, streams builder, and KStream in particular. And then we instantiate a new streams builder object. looks like it's calling the stream method and storing the result in word counts here because it's specifying the type of word counts, the variable word counts, to be string long. So it's calling the builder library, the stream method from that library, and specifying the name of the topic, which helpfully the comments tell me here. The name of the input topic is word counts input topic, and it's consumed with, so that's the second argument to the stream method, is another function, and it's consumed with, and that takes in, I guess, the serializer, deserializer, the Serdes key, and the Serdes value, and that can be a string and a long, at least in this case. Oh, that kind of makes sense because we're getting word counts, so the key is going to be a word like hello, yeah, or Beethoven, and then long will be the word count, so that'll be, in this text, the word hello appears 2 times, and the word Beethoven 100 times. If you do not specify Serdes explicitly, the default Serdes from the configuration are used. Okay, I'm curious what the default Serdes is. So if we look at default here, optional, okay, default key Serdes, that is a value in the config. The default serializer deserializer class for record values. Serialization and deserialization in Kafka Streams happens whenever data needs to be materialized. For example, whenever data is read from or written to a Kafka topic, example via the streams builder stream, which we were just looking at, and KStream #2 methods, or whenever data is read from or written to a state store. Okay, so there is a default serializer. I wonder though, what is the default like out of the box when you install it? Oh, it's discussed more here. Data types and serialization. Okay, I'm going to leave that as an open question that I might come back to, is how are you going to have a default serializer, deserializer? Doesn't it depend on the application? I might come back to that. All right, but not to get too stuck on that for now, it says you must specify Serdes explicitly if the key or value types of the records in the Kafka input topics do not match the configured default Serdes. Okay, so if the key and value of the records in the input topic just happen to match the default Serdes, great, but otherwise it is required to explicitly specify those, which makes sense. For information about configuring default Serdes, available Serdes, and implementing your own custom Serdes, see data types and serialization. Several variants of stream exist. For example, you can specify a regex pattern for input topics to read from. Note that all matching topics will be part of the same input topic group, and the work will not be parallelized for different topics if subscribed to in this way. Oh, that's interesting. So if you set a regex pattern to subscribe to create a stream from input topics, then it's going to take any matching topic and put it into that stream and not parallelize it. I guess at least not by default. So maybe that's one reason. I think I heard Tim Berglund say on one of the informational videos on Confluent's YouTube channel that that's something you need to watch out for. Or he said, regex is not for the faint of heart, I guess, because sometimes you might not know what you're subscribing to then and how it's going to be parallelized, or I guess not parallelized. Say that word 10 times fast, parallelized. Okay, second type of creating source streams from Kafka is table. So an input topic into a KTable. Oh, I just realized why there's always this input topic and an arrow, because I guess you're not going to write data from a producer directly into a stream. It's always first going to go into a topic, then into a stream, then back into a topic, and then to a producer, I think. So table reads the specified Kafka input topic into a KTable. The topic is interpreted as a changelog stream where records with the same key are interpreted as upsert, aka insert update, when the record value is not null, or as delete, when the value is null for that key. Yeah, I think we went over that in the last video, that with the KTable, the updates or new values for the same key are interpreted as upserts, and if you write a null for an existing key, it's interpreted as a delete. Okay, so in the case of a KTable, the local KTable instance of every application instance will be populated with data from only a subset of the partitions of the input topic. Collectively, across all application instances, all input topic partitions are read and processed. Okay, so that's the same as with the KStream for horizontal scalability purposes, probably. Okay, so that's the same as the KStream. The KTable also makes it horizontally scalable by having only a subset of the partitions on any given instance, but when you sum up all the instances used for the stream, you've got all the partitions present and processed and read. So moving on, you must provide a name for the table, more precisely for the internal state store that backs the table. Okay, so there is a state store for the table. I want to learn more about that, by the way. That's a really interesting topic, how Kafka handles state internally, especially for tables, but I'll leave that as an open question to come back to. If you do not specify Serdes explicitly, the default Serdes from the configuration are used. Okay, so that's the same as with KStream as well. You must specify Serdes explicitly if the key or value types of the records in the Kafka input topics do not match the configured default Serdes. For more information about configuring default Serdes, yada yada yada. Same thing as before with the KStream. Several variants of table exist, same as with stream, which also has several variants. For example, to specify the auto offset reset policy to be used when reading from the input topic. Oh, okay. I guess you get several variants of table by specifying different policies and configurations. So depending on what settings you set on the table, that's a different variant, a different flavor of the table. That's how I'm reading this at least. Okay, global table. Input topic to global KTable. Global table reads the specified Kafka input topic into a global KTable. The topic is interpreted as a changelog stream where records with the same key are interpreted as upsert, aka insert update, when the record value is not null, or as delete when the value is null for that key. So same as table so far. In the case of a global KTable, the local global KTable instance of every application instance will be populated with data from all the partitions of the input topic. Okay, so every single application instance gets the data from all the partitions. So I guess you gotta have some hefty machines there to do that in some cases. You must provide a name for the table, more precisely for the internal state store that backs the table. Okay, so that's the same as a table. But going back to this one, I'm curious how scalable a global KTable can be. Every instance of it gets data from all the partitions. Another open question. You must provide a name for the table, more precisely for the internal state store that backs the table. This is required for supporting interactive queries against the table. When a name is not provided, the table will not be queryable and an internal name will be provided for the state store. Okay, so that part was the same. And then, unlike in the table section, in the global KTable, they do provide another example code, and it looks about the same, but let's see, what are the differences here between the global KTable and the streams creation here? We're still importing Serdes stream builder, but this time instead of importing KStream.KStream, we're importing KStream.global KTable. Well, this is the same. We're still creating a streams builder object. Then we're still doing a words count, the same example, but this time the object type here is global KTable, and we're not doing builder.global KTable as the method instead of builder.stream, and we're still needing to specify that input topic. Well, actually, it's consumed.with for the KStream, and then just the Serdes information. Whereas with the global KTable, it is materialized dot. And here you would put in string long key value store 3 values, I guess. and that's either a bytes or byte array. And then the string would be the table store name, like what you want to materialize it as. Word counts global store to support those interactive queries of the table. So the parameters are kind of the same as with the KStream, with the addition of having a table name to specify and slightly different serialization methods. Instead of Serdes dot, you've got with key Serdes and with key value Serdes as dot notation here. Okay, we're coming to the end of the section on creating source streams from Kafka. The final part about global KTables here is that you must specify Serdes explicitly if the key or value types of the records in the Kafka input topics do not match the configured default Serdes. Okay, so and this last part is the same for KStream, KTable, Global KTable. I'll just read these last two sentences anyway. For information about configuring default Serdes, available Serdes, and implementing your own custom Serdes, see data types and serialization. Several variants of Global Table exist to example, specify explicit Serdes. Cool. You heard it straight from the documentation. I hope this video helped. Please like if you liked it, and subscribe for more videos like this, and comment if you have any explanations to add to what we just studied here. And in the next video, we'll be studying transform a stream. So join me next time to study with me for transforming a stream in Apache Kafka. And until next time, thanks.